Good morning, student. Myself Pungali from EC department. Welcome you for Digital Principles and Computer Organization class. And today, actually, we are going to learn about the logical configurations of shift registers, types of shift registers, and working principle of SISO and SIPO. Shift register finds application in digital circuits for variety of applications, including data storage, serial to parallel and parallel to serial data conversion, shift and rotate operations, and frequency division. And they are also used in communication systems such as in serial data transmission and reception. So a register which is capable of shifting the binary information held in each cell to its neighboring cell in a selected direction is called as shift register. So if you see the logical configuration of a shift register, it consists of chain of 4 flip-flops in cascade with the output of one flip-flop being connected to the input of the next flip-flop. So the data is shifted from one flip-flop to another either in serial or parallel, and the information in form of bits can be made to move out or move in from these registers with the help of clock pulse. Now we'll see the block diagram of shift registers. Here it has been constructed with the 4 D flip-flops, and all the clock signals of the D flip-flops have been given same clock pulse, and we have single data input line and 4 data output line Q1, Q2, Q3 and Q4. So based on how binary information is entered or shifted out, shift registers are classified into 4 categories: serial in, serial out shift register, serial in, parallel out shift register, parallel in, parallel out shift register, and parallel in, serial out shift register. So here we have the block diagram for the various types of shift register. First we have SISO, that is serial data in and serial data out. Here we have single data input line and we have single data output line. In the case of parallel data in and parallel data out, we have 4 data input lines and we have 4 output lines. In the case of serial input and parallel output, we have single data input line and we have 4 parallel data output line. So for PISO, we have 4 parallel data input line and we have single input output line. So if you see in detail the serial in, serial out shift register, which allows serial input and it produces a serial output, hence it is known as SISO shift register. We can build this circuit with the help of 4 flip-flops, SR flip-flops, which are connected in serial manner, and all these flip-flops are synchronous with each other since same clock signal is applied to each flip-flop. And if you see, the main use of SISO is to act as a delay element. Here we have a logical circuit diagram of a SISO. We have taken 4 SR flip-flops and all the clock signals of the SR flip-flops have given a single same clock pulse, and here we have a serial input line where S and R have been tied to give this common input. So we have the serial input like 1010 is available and it will be shifted for the each clock pulse to the respective registers. Okay, now if you see here for the first clock pulse, if the input is 0, the output is going to be 1000, and for the second clock pulse, if the input is 1, the output is going to be 0100, and for the third clock pulse, for the input 0, the output will be 1010, and for the fourth clock pulse, if the input is 1, the output will be 0101. So the truth table clearly shows initially when there is no clock pulse, all the output of the flip-flop remains in the reset state. As soon as the clock pulse is initiated, then immediately the bits will be shifted from one flip-flop to other. So that's why it has been given in the waveform, clock waveform. So we can clearly understand that for initially the Q1, Q2, Q3 and 4 remains in the 0 state. And in this case, it has been the bits have been shifted and we are getting the output like 01010 for the Q1, and for Q2 0010. If you see the waveform, you'll be able to understand, and Q3 it will be 000 and 10, and for Q4 if you notice initially it will be 0, and as soon as the last data comes in it will be reaching the high state. So for serial and parallel shift register, which allows serial input and parallel output, and here the input data is given bit by bit serially, and for each clock pulse the input data at all flip-flops can be shifted by single position. So the output at every flip-flop can be received parallel. An SIPO circuit can be built with 4 D flip-flops which are connected as shown in the diagram, and here a clear signal is given additionally to the clock signal, so to all the flip-flops to reset them. So here we have a logical diagram for SIPO, and we have set the data input as 1101, and if you see the truth table, you will be able to understand for the initially when the clock pulse is 0, the flip-flop output remains the same, and as soon as the clock pulse is initiated, the bits have been shifted. So for the first clock pulse, the Q will be 1, QB 0 and QC 0 and QD 0. For the second clock pulse, the Q1 is shifted to QB, 0 is shifted to QC, and 0 is shifted to QD. So similarly, the bits will be shifted. And finally, if you see for the fourth clock pulse, the QA1 will be shifted to QB, and 0 will be shifted to QC, and 1 will be shifted to QD. Hope you would have understood this class. And next class we will be able to we will be concentrating on sequential circuits. Thank you.